Hello everyone, my name is Muhammad Akmal bin Matno, and today I will make a video for my assignment BMMA 1313, which is Principle of Electrical and Electronic. The topic that I will cover today is Nodal Analysis. Okay, let's start with the introduction. The definition of nodal analysis is the node voltage is referred as the potential difference between two nodes of a circuit. We select one of the nodes in our circuit to be the reference node. All the other nodes' voltage are measured with respect to this one reference node. In nodal, current always flow through high potential voltage to low potential voltage. There are methods to analyze the circuit which consists of 5 steps. First one is we need to identify all the nodes. Second one, we need to set the reference node. Third one, label the nodes. Fourth is to write the equation using Kirchhoff current law, KCL. And number 5 is to solve the equation. Okay, next. First one, we need to identify the nodes. So here we have 4 nodes. And the next step is step 2. We need to set the reference node. Okay. Our example circuit has 4 nodes. So we have to choose the nodes that has a lot of connection. In this situation, the node C and node D. Basically, we can combine these two nodes and make it as a reference node. So here is our reference node. Okay, there are 3 common symbols for indicating the reference nodes, and I'm using the second one. Okay, we're done with the reference nodes, and the third one is label the nodes. Okay, after we choose the reference node, we need to label the nodes. Here is my VA, and here is VB, and here is VC. Okay, this is our 3 nodes now that we're gonna use to solve the equation in this circuit. So we are done with the label the nodes. Next, you need to write the equation using KCL. But first, we need to remember that the current in nodal is always flow from high potential to low potential. This one, the current will flow from 0 to 12 volt, and like this one, VA will flow to the reference node, which is a 0 voltage. This one, VB, also will flow to the reference node, and this one, 0 voltage to 6 voltage here. Okay, this is a example. Okay, this one is the current flow from 0 to 12 volt. So here is our potential voltage, which is 12 volt. Second one is here, which is current flow from 0 to 6 volt, and the potential voltage is 6 volt here. Now I'm gonna make an arrow indicator where the current gonna flow. So first one, the current gonna go through from here 12 volt to VA, and from VA we leave the node to 0 voltage, which is reference nodes, and from VA gonna go through VB. Same like this one, the VB, the current will go through the VB from VA and entering the nodes. Next, it will leave the nodes and go to the reference node, and the current from 6 volt here gonna enter the node VB. After we make an indicator, we need to label it. So here is I1, I2, I3, I4, and I5. Okay, next we can write the KCL equation for each I1 to I5. This is the formula for KCL. And for I1, the current is from here 12 volt to VA. Always remember that the current will always flow through the high potential voltage to low potential voltage. So the current gonna flow from 12 volt to VA, divide by the resistor, which is 10. For I2, the current will go through from VA to the reference node, and divided by the resistor, which is 5. For I3, because the current flow through VA to VB, so we need to put VA minus VB and divide by the resistor, which is 10. For I4, the current from VB gonna went through the reference nodes and divided by resistor, which is 10. For I5, the current from 6 volt, which is our potential voltage, will go through to VB and divided by resistor, which is 5. Okay, now we can apply the KCL for each node, which is VA and VB. Okay, for VA, we're going to apply the KCL at node VA. The equation is I1 positive because the current go through the nodes, and minus I2 because the current is leaving the node, and next the I3 because the current is also leaving to VB, equal to 0. Okay, we just need to substitute the equation from this and put in at the KCL equation. Okay, for I1, we can put 12 volt minus VA divided by 10 minus I2, which is VA minus 0 divided by 5, and for I3, VA minus VB divided by 10 equal to 0. Okay, so we can solve the equation by multiply by 10 to make it easier to divide all this denominator. So after we calculate, we get this answer, which is 12 minus VA minus 2VA minus VA minus VB equal to 0. And the last answer is 4VA minus VB equal to 12. Okay, this is our first equation. Okay, now we're going to apply the KCL for node B. For node B, we have I3, I4, and I5. The equation will be like this. I3 positive because the current went through the nodes and leaving by I4, and I5 because the current from 6 voltage go into the low potential voltage, which is VB, equal to 0. And same like KCL for node A, we just gonna substitute this into this equation. Okay, can get the answer, which is like this, and we can solve by multiply by 10, and then we can get the answer, which is VA minus VB minus VB plus 12 plus minus 2VB equal to 0. The final answer for equation 2 is this. VA minus 4VB equal to negative 12. Okay, this is our second equation. Okay, we are done with the writing the equation using KCL. So last, we're going to solve the equation using our equation 1 and equation 2. Okay, we're going to put the equation 1 here and equation 2 because we're going to subtract the equation 1 with equation 2. But first, I'm gonna multiply equation 2 with 4 because it will make it easier to subtract with the equation 1. So this is the result. The answer is 4 minus 4 is 0. And then BB plus 16, which is the answer is 15 BB. And 12 plus 48 is 60. So VB equal to 4 volt. And we're gonna use this VB and put into the second equation to find VA. VA minus 4 VB, which is 4, equal to negative 12. So VA is equal to negative 12 plus 16. VA equal to 4 volt. Okay. VA is equal to 4 volt and VB equal to 4 volt here. Okay, we are done with solving the equation. So by using nodal, we also can get the current from the circuit, which is we use the information VA and VB, and we can substitute in this current equation. Okay, the first one we get for I1 here is 0.8 ampere. Second one, I2 is also 0.8 ampere. I3 is 0 ampere, so there is no current flow here. So I4 equal to 0.4 ampere and I5 equal to 0.4 ampere. Okay, that's all from me. Thank you very much.